but our predictor is actually going to be a categorical variable. Okay, our predictor is going to be a categorical variable. So if I have a categorical variable, so how do I still run my regression? Is that going to be, is that one going to be a little bit different from what we have been doing? Of course, we're actually going to uh, find out after today's lecture. Okay, so uh, because of that, we got this goal. Number one, you will be able to understand what is dummy variable, and you will be able to fit regression model with dummy variable as a predictor variable. Okay, so that is the goal of this lecture. Okay, so I'm actually going to start with what do we mean by dummy variable. Let me tell you, in a situation where your predictor, okay, can actually be categorized, okay, into two, in such a way that you're actually going to have a control group and you're going to have an experimental group. Let me say that again, you know, where when your predictor actually is categorical in nature, okay, uh, where you can classify into a control group and experimental group in such a way that the control group you're going to assign 0 and experimental group you're going to assign 1. Okay, and that was the reason why I said, it's a variable that can take on different values. Okay, 0 or 1. So the 0 or 1 that we're trying to talk about here is more or less like a binomial. Okay, it's more or less like, okay, I got two levels of categories. Okay, and a typical example of that is when I look at gender. Okay, when I look at gender, where of course the gender is categorized into male and female. So I can decide to assign 0 to male and assign 1 to female. Okay, so that doesn't mean having 1 or having 0 does not mean this is greater than this. No, it doesn't. Okay, that is a label of categorization. Okay, it's just like when you look at zip code. Okay, zip code is more or less like a qualitative and not quantitative. Okay, if I'm living at 5544 MN 55447 and somebody is living at MN 55429, that doesn't mean that somebody who have a bigger value is bigger than the other one. Okay, it's just way to label uh, two places that are not actually the same. Okay, so like I said, I can also switch that. Okay, I can also switch that. Okay, and like I said, 1 is not necessarily better than 0 or vice versa. Okay, now the next thing I want to talk about now, can we have an example of a dummy variable? There are some questions that we may actually want to ask. Maybe we got a question and we want to provide an answer to that. Okay, so at times it could fall under a dummy variable regression. And how am I going to know? Take a look at the question right here. What is the relationship between wage and marital status in 1985? Okay, the essence of this research is just to be able to figure out if being married or single actually determine the wages. Okay, so that's exactly what we want to see right here. So the data is actually a random sample from 1985 current population survey. And if you look at the X right here, which is a predictor, is the marital status that we're actually talking about. Okay, so the respondents, they were classified into being married or single. Okay, they were classified into being married or single, and this is the response variable, which is wage. Okay, and that is measured in hourly wage in dollars. Okay, now the sample size of data collected is actually shown right here. We collected a data set from 6 individuals. Okay, uh, if you look at in these 6 individuals, it is only one person that is single. Okay, it is only one person that is single. But let me just tell you that based on the data set that I'm showing right now, okay, based on the data set that I'm showing right now, uh, it's only one person that is single. But the data set that we use is actually more than this. I'm just trying to show you the first 1 to 6. Okay, now if I have this particular data set, okay, I'm actually going to have what I call descriptive analysis before I go inferential. And what is a descriptive analysis? I actually need a descriptive plot since the nature of the nature of the predictor is categorical. Okay, then I can draw a box plot. Okay, now if you look at what I have right here, okay, this is a box plot, okay, for the data set. Okay, so here I plotted the wage against married and single, and this is the one for the married. It means the data set for the married on wage, okay, we actually construct this box plot. Okay, and this is for the single. Okay, and before you go into what I call differential statistics, this will enable you to compare. Okay, so of course in a box plot we have 5 number summary. Okay, we have 5 number summary in a box plot. Okay, we got the minimum, we got the maximum, we got the first quartile, the second quartile, and the third quartile. Okay, now if you look at what I'm pointing at the moment, okay, this is the median. Okay, this is like the median wage of the married. Okay, this is the median wage of this single. Okay, so when you compare this box plot with this box plot, okay, you're actually going to see that the median wage for the married is actually bigger than the median wage of this single. Okay, but you know what? This is what we can see from this box plot. Uh, where this will make us to suspect that different marital status have a different wage experience. Okay, we are suspecting that. Okay, uh, the plot, the descriptive statistics that we always need to do descriptive statistics in statistical investigation, because the descriptive statistics will actually enable us, you know, to be able uh, to see what we are suspecting. Okay, it's going to be able to we'll be able to see from the chart of something that we may be suspecting. Okay, and then that is the reason why that is what we need to do first. Okay, we call it preliminary investigation before we go into inferential statistics. Okay, this is exactly what we can say. So we are actually suspecting that the median wage of the married people are actually higher than the median wage of the single people. But we cannot just conclude that based on the plots. Okay, we cannot conclude based on the plot. We actually need to go inferential to be able to provide an answer to that. Okay, so based on the data, so on this data right now, I'm going to be putting putting 0 and 1. Okay, I can let married to be 0. I can then single to be 1. Okay, I'm going to assign 0 and 1 to that. Okay, now uh using the data set, okay, we can actually uh we're going to run a linear regression model. Okay, this is the wage, which is the response. Okay, and of course this is the predictor status. Okay, the status here is categorical. Okay, and this is just to showcase the data set that I'm actually going to be using. Okay, so when I find a summary of that, okay, this is what I have. Can you see that now? This is exactly what I have. But there's something that I want you to see, you know, that it will make it to be different from the output here. It's going to be a little bit different from the output of linear regression model when the predictor is not categorical. Okay, now when you take a look at this right here, you're going to see status single. Okay, what is going to declare right here, despite the fact that we got to what is it called, we got to uh categories, it's actually going to disclose only one. Okay, right here is disclosing single. Okay, so since it's disclosing single, it's making married to be response. I mean, to be a point of response. Okay, so in when you run dummy regression model, okay, when the number of levels is 2, okay, it's always going to disclose 1. Okay, that's why you see status single. Okay, now if I have this one now, when I have status single, okay, what do we uh, actually mean? Now, let me tell you that our model still remain y equal beta naught plus beta 1 x. Okay, I'm going to say that again. Y equal beta naught plus beta 1 x. Okay, so if y equal to beta naught plus beta 1 x, okay, if beta 1 equal to 0, what happened? Okay, if beta 1, okay, equal to 0, okay, you're going to notice that if beta 1 equal to 0, then we're trying to say that single and married, they have the same experience in terms of the wage. I'm going to say that again. If beta 1 equal to 0, okay, in the simple linear regression model, y equal to beta naught plus beta 1 x, okay, if beta 1 equal to 0, okay, what we're trying to say is that the single and married, they're actually going to have they have more or less the same wages. Okay, but in the situation where beta 1 is not equal to 0, okay, if we're going to have an hypothesis that we're actually going to test on that. Okay, if we carry out the hypothesis testing on this beta 1, okay, and I showed you before how to carry out an hypothesis testing regarding beta 1. Under the non-hypothesis, of course, you're going to have a beta 1 equal to 0, and under the alternative, beta 1 not equal to 0. Okay, and if you want to test that, of course, your test statistic is actually going to be the ratio of the beta 1 cap to the standard error. Okay, and take a look at this guy right here. This is the estimate of of the beta 1. Okay, this is the standard error. Okay, so this guy divided by this guy actually give this guy. Okay, and this is the p-value associated with the test. Okay, this is the p-value associated with the test. Okay, if you want to take a decision right now, okay, you can actually take a decision regarding the significance of beta 1. Okay, but there's something at 5% level of significance, the p-value here, is this is less than 0.05, which means it's significant, right? But there's another thing I want you to see. Look at the R squared. What do you notice in the R square here? The R square is very, very small. Okay, and when the R square is small like that, okay, it means you got a poor model. Okay, because I told you the other time that R squared determine the degree of adequacy of a model. Okay, the degree of adequacy of a model, that is what R square, and R square should go from 0 to 1. Okay, but this guy here is very, very small. Okay, and when it is very, very small like this, then it means we may not be able to rely on this result. Okay, then what are we going to do? Okay, now based on what we have for now, based on what we have, okay, if you take a look at the output, I'm going to show you something. If I want to, based on the model that we have right now, okay, based on the model, so using the estimate, the combination of the estimate, okay, I'm actually going to have this. Okay, I'm going to have this one. Though I told you that this is more or less like a poor model because of the R square value. The R square is so small. Okay, because if I want to interpret this one, if I multiply this by 100, okay, uh you know if you look at it 0.01, if you multiply by 100, that is more or less like 1%. Okay, and that is extremely small, okay, but we're still coming back to that. Okay, but right now let us assume that everything is good. Okay, let's say we have, what is a model that we just fitted? This is a model right now. Okay, now the status single is like the variable that we are actually using in the predictor. Okay, now let me interpret this for you. When status equal to 0, okay, when status equal to 0, okay, that is married. Don't forget that I said we're going to, for status, the married, we're going to use 1, and for single, we're going to use 0. Okay, I'm going to say that again. For married, we're going to use 1. For single, we're going to use 0. And you know what? It doesn't really matter. Okay, you can actually use 0 for married. You can use 1 for the other one. So you can switch it. It doesn't really matter. But you know what? When you are switching it, okay, this will not be a single. Like, let me tell you what is done here right now. I'm actually going to tell you what is done here right now. Okay, when status equal to 0, 0 here is for married. Okay, we use a 0 here for married. Okay, here our married is 0. Okay, the single is 1. I'm going to say that again. Based on this analysis that we're doing, though you can switch that, but if you want to use if you want married to be 0, okay, and single to be 1, the one that you are referring to 1 is the one that should appear in your status. I'm going to say that again. What did I put right here? Status single, because I'm denoting single to be 1. That is why it is part of the status here. Okay, status single. So it means married is more or less my point of reference. I'm going to say that again. Married, because I denote married to be 0, and I'm denoting single to be 1. Because of that, I'm going to write status single. Okay, if I denote single to be 0 and married to be 1, then I'm going to have status married. Does that make sense to you now? Okay, so I got a status single because my single is 1. Now, if you go back to the model, okay, if I come back to this model, okay, when this equal to 0, when this guy here equal to 0, what am I referring to? I'm referring to married. Okay, when this guy equal to 0, okay, the wages is going to be 9.40. Okay, when this guy equal to 0, the wages is going to be 9.40. But when this guy equal to 1, when this guy equal to 1, I'm talking about single. When this guy equal to 1, I'm talking about single. Of course, if this guy equal to 1, I'm going to have 9.40 minus this. And of course, what you are going to have will be less than married, will be less than the wage of married. Okay? So using this model now, okay, on average, okay, the wage of married will be more than the wage of single. Okay? And the preliminary investigation that we have done right here has justified that. Look at the box plot. This box plot has already shown us here that the median of the married, the median wage of the married is higher than the median wage of the single. Okay, and that exactly that is in conformity with the model, the result that we have here right now. Okay, I'm going to repeat myself again. When the status single, okay, equal to 1, okay, when the status single equal to 1, you are actually going to determine the wage of single. When the status single equal to 0, okay, you are actually going to determine the wage of married. Okay, so I've been able to interpret the the parameters in the model. Okay, I've been able to interpret that because when the status single equal to 0, okay, we're actually going to have an intercept. Okay, so which means that intercept is the value of the point of reference. What is the point of reference? So the point of reference is a married. Okay, it means we are putting married in the control group. I'm going to say that again. We are putting married in the control group, and we're putting single in the experimental group. Okay, so when the status single equal to 0, then it means you are referring to the baseline, which is the intercept, which is the value of the married. Okay, and don't forget the married is being categorized into is in a control group. Okay, and if I want to look at the one in the experimental group, I'm actually going to say status single equal to 1, then I will be able to determine the wage. And you know what is happening here? This is trying to say for any unit increase in that, of course, the value of this is actually going to go down by 1.09. Okay, now we have interpreted the intercept. Okay, we interpreted the intercept because of the fact that what can actually give us the intercept right here is the baseline. Okay, is when the status single equal to 0. Okay, now let us now go and interpret the estimated slope, which is 1.09, this guy right here. Okay, let me tell you that this is the beta 1. Okay, and if beta 1 equal to 0, okay, if this guy here is not different from 0, we're actually going to have the control. Okay, we're actually going to have the point of reference. Okay, so in a way, interpreting the estimated slope is more or less that we are comparing two groups. Okay, because when beta 1 equal to 0, okay, it means the difference between the two group is 0. Okay, and when beta 1 is not equal to 0, then it means there's a difference between two groups. Okay, because of that, we're actually going to have consider something like this. Okay, it's more or less like, okay, this guy here is the average wage of single. Okay, this guy here is the average wages of married. Okay, so the difference between the averages of this mean is actually going to be beta 1 cap. Okay, it's actually the beta 1 cap, and we actually need to see we need to test this statistically to be able to see if beta 1 cap equal to 0. Okay, we need to see whether the beta 1 cap equal to 0. Okay, because if the beta 1 cap is equal to 0, then it means there is no significant difference in the average wages of the two group. That is the meaning. Okay, so because of that, this is more or less actually going to take us to testing this. Okay, it's actually going to take us to testing beta 1 equal to 0. And you know what? It means testing the beta 1 equal to 0 is equivalent to the two sample t-test. Why is it equivalent to two sample t-tests? Because I told you something right here that uh, the difference of the mean is going to be beta 1. And if I'm testing beta 1 equal to 0, then I'm actually testing the equality of the quality of the means of two groups. Okay? And based on what you have done before in statistics, that is a t-test. Okay? That is more or less like a t-test. Okay? Now take a look at that here. Okay? So we believe that testing for this right now, we're actually going to be testing the equivalent of the means. Okay, so the under the known hypothesis, this is going to tell us that, okay, you know what, the population wages, the population mean the wages of the married people is the same thing as the population mean of the wages of the single. Why in the alternative they are not the same? Okay, can you see that now? Okay, so when you have something like that, okay, like I said, I showed you the bus plot the other time. This is the bus plot. So if you want to do that, of course, we're going to make use of this formula right here. Do you remember what you did under the t-test? Okay, the two sample t-test. Okay, so this is the mean of wages of single. This is the mean of wages of married. Okay, and of course, this guy here is actually going to be a pool standard deviation. Okay, and of course the NM here is just what is the sample size of married uh, participant in the data set we're considering, and what is the sample size of this single. Okay, so based on the data we have, we can actually compute this guy here. Okay, and when we do that, we have a t value to be this, and the p value associated with that is a 0.02009. Okay, if you look at the p value right here, let's compare it with the p value that we have in the regression. This is 0.02009. Let's go back to the one we have in the regression. Now, if you look at the p-value that we have in the regression, we got a 0.020. Can you see now? So this guy here, the p-value that we have right here is more or less the same as the p-value that we have here. In fact, it's the same. Okay, to 3 to 4 decimal. Can you see that now? So so if what you get from here, if you do the uh, the two tests, the t-test, two tests of means, the result that you're actually going to have is still going to be the same result that you're going to have when you do when you run the simple linear regression. Okay, but you know what? The fact remain that uh, this is not a good model. Okay, this is not a good model because of the fact that the R square is very, very low. Okay, I'm going to tell you in the subsequent lecture what we can do. Okay, if the R square is very small like this, though this is a technique that we can use, but we also need to check on the R squared. Okay, so what I've showed you right now is just for you to see the a relationship between uh you know a relationship between um conducting the significant test on the beta one, well, when we are talking about dummy variable regression, and when you are performing uh you know a t-test of difference of means. Okay, they are the same. Okay, is there any one of you who want to ask question before I move on? Is there anyone? uh can you guys hear me?
Yes.
Okay. So if there is anyone who need clarification, okay, I'm actually going to explain right now. Okay, let me read my chart. Somebody said, could you explain what is SPL again? Okay, so I'm actually going to explain. The SP here is what we call the pool standard deviation. Okay, pool standard deviation. Okay, you have done in your lower for those of you who have done 3011, 3021, I believe you must have done something that we call pool variance. Okay, pool variance, we got a formula to compute the pool variance. But you know what, you are not going to compute this way. We can also do this in R. Okay, there's a way you can actually conduct a t-test in R. Okay, so you don't need to worry more about that. But this guy here has a formula. Okay, this guy here actually has a formula. Like for instance, the pool variance is uh, is going to be nm minus 1, okay, x1 squared, which is the variance of that group. Now, plus ns minus 1 s2 squared, then divided by nm plus ns minus 2. So we have a pool variance formula. Then when you find the square root of that, it's going to give you pool standard deviation, but you don't need to worry about that for now. Okay, so what you just need to focus on is, okay, how can I implement this in R? Okay, so now somebody said, yes, you stated before for the RLM command for the non hypothesis equal to 0, we get a T and P value on the output, but this is not the case for this example. Uh, can you explain? Okay, if you look at this example right here, if you look at the example right here, it's more or less like running linear regression. The same way you run linear regression. Look at the code, the same way. And look at what we have. This is similar to the table. It's just the same. The only thing is that the predictor here is categorical, okay? And of course, if I want to test beta 1, okay, if I want to test that beta 1 equal to 0, of course, I'm going to use the p-value right here, okay? Because in the testing of beta 1 equal to 0, if I want to state the procedure, you're going to start by writing beta h naught, beta naught, beta 1 equal to 0, okay, versus h a beta 1 not equal to 0. Okay, then you're going to state your test statistic. What is your test statistic? It's actually going to be the estimate divided by standard error. Okay, estimate is divided by standard error will give you the t value. Okay, and this is the p value associated with the t value. Okay, so if I want to know how significant is my beta 1, this is the guy that I'm going to check. Okay, I'm actually going to compare this guy with the level of significance. Okay, and that's exactly the same thing that we've been doing. Okay, but well, I'm trying to say another way to do that, because we're dealing with a dummy. we can do a significant test on two means. Look at that. Because the beta one that we're talking about is the difference between the mean of the first group and the second group. And you know, in a dummy regression, the predictor is being partitioned into two groups. Okay, so these are the two groups that we're talking about. This is the mean. This is the mean wages of singles in that place of work. This is the mean wages of married. Okay, so testing beta 1 equal to 0 is more or less like testing whether the difference of this equal to 0. Okay, which is significant, which is equivalent to t-test that you have done before. Okay, so what I'm trying to tell you now is just that, okay, the t-test that you have done before and this and the test on significance of beta 1 equal to 0, they are the same. And that is the reason why in the end, we actually have, look at the p-value. Okay, so if you want to run this in R, what you can do is you just need to write t.test, okay, t.test into the two variables. You're going to see the outputs. Okay, so my TA is actually going to walk you through that. Okay, so this is the domain variable. Okay, so next week I'm going to go further on this. I'm going to attach another material because we still have other things that we can also do in domain variable. But this is just to introduce you guys to domain variable. Before I move to the next topic, is there anyone who want to ask question on the domain variable? Okay, in the absence of question on the domain, I want to introduce you to another important topic today. And the topic today, the topic is, give me 1 second. I'm actually going to share that now.